Hi, and welcome to Chapter 7, Chemical Reactions. This is an awesome chapter. I'm really excited about this one. This is basically chemicals and atoms and explosions and acids and bases and all this really fun stuff that we're going to get to do in class, and some awesome videos too, hopefully. So let's get straight into it. So really what we're talking about here for this entire chapter is how atoms rearrange themselves to make various chemicals that we can use for a variety of industrial research, medical, whatever else we're using them for. So that's really what we're talking about today. And this little diagram here that you're seeing here is the core of what we're talking about here. Really what we're meaning when we're talking about chemical reactions is we're talking about, two atoms or a couple of atoms, bonding with another chemical. Okay, in this case it's hydrogen. Hydrogen gas has two hydrogen atoms. This is another hydrogen molecule here, a hydrogen gas with two hydrogen atoms bonding with an oxygen molecule, which has two oxygen atoms, one oxygen atom, two oxygen atoms, and they bond together under the presence of heat, a considerable amount of heat at times. And then we have an arrow to show that a chemical reaction has occurred, okay? And then what we end up with is an oxygen and two hydrogen atoms here, and this of course is water. We usually have a plus in here as well. Usually there's a plus. So this is really what we're talking about here. Now normally it's the H2, H2, O2, and then an arrow, and then H2O. Okay? And if we were to represent that, let's see if we can actually draw it. Okay? So it'll be H2 plus O2 in the presence of heat, being H2O. Now, the important thing here is that we've actually got two hydrogen molecules here, so we'll need to do some balancing. Okay, so it's actually two of these. Okay, there's only one oxygen and there's two waters over here. Okay, so we can see that that's balanced. And this is our chemical equation here. Okay, our hydrogen, which is equaling these, our oxygen, which is equaling that, our arrow, and then our two water molecules. Okay, congratulations, that's your first chemical equation. Easy as that, easy as pie. Okay, now the only other thing I want you to know about this is a bit of terminology, that everything on this side is called the reactants. These are what react together, and everything on the other side is the products. Now, it's not always only one thing. Sometimes it's a variety of things, being, it might be water plus some acid, or water plus, whatever it is, okay? But what you're going to find is that everything that's on this side has to be represented over here. Okay, so let's have a look to see if I've got that right. So there's 2 times 2 hydrogen atoms, so there's 4 hydrogen atoms. 2 times 2 hydrogen atoms, there's 4 hydrogen atoms. Okay, so that matches up, right? That's balanced. All right, good. All right, we've got 2 oxygen atoms here, and we've got 2 oxygen atoms there. So that balances out as well. So that's really good. And that's what we're going to be talking about next. So let's have a look. So there was, in the 18th century, there was a guy called Antoine Lavoisier, something like that. It's in French. I'm not going to try to put on a French accent for you. And he was looking at a candle, and what he was noticing was that although it seemed like the candle was burning, well, it was burning, but it seemed like the wax was disappearing into nothing. Okay, and that was the established thought at the time. You burn a candle, and you're burning the wax, and it disappears into nothing. And that sounds ridiculous to us today, but you've got to realize, it's the intuitive thought, right? It's an intuitive thought that if you burn something and the candle wax and the candle itself disappears and it just goes down and down and down, the idea that it turns into this magical, invisible nothing is a bit odd, all right? But that's exactly, of course, what's happening. And this is called the law of conservation of mass, okay? So what this is really saying is when the candle is burning, when the wax is burning, it obviously turns into a gas, okay? And as it turns into a gas, if you took the amount of gas up here, all right, and weighed it in some way, or said that you compared that amount of gas, mass in the gas, I know that's confusing, but the amount of mass, it would be equal to the amount of mass in the candle. So I want to say that really clearly. When you undergo a chemical reaction or any kind of reaction, you cannot create or destroy mass. You cannot create or destroy mass, except under very particular quantum kind of, large nuclear explosion type things. But that's not a candle. Let's leave that to the side. We're talking about candles here. So when you undergo basic chemical reactions, you certainly can't create or destroy mass. And that's what we were talking about before with the hydrogen and oxygen. Notice how we made them balance, right? So you can't all of a sudden have an extra oxygen appearing, you know what I mean? Or you can't have some oxygen disappearing entirely from the equation, all right? So if you ever catch me doing that, call me up on it and say, hey, Mr. Wilcox, you've got to make sure that you obey the law of conservation of mass, okay? So that's the first law that he discovered, the law of conservation of mass. So the amount of mass is conserved both before and after. Okay? So the second thing that he really talked about, that we're going to discuss anyway, was the law of constant proportions. Now what this is saying, for example, let's give an example here, grab a pen, is CO2. Okay? This is carbon dioxide. All right? Now, what he said is that if there's CO2, then the atoms that will be found in CO2 will always have the same proportions. So that means it's always a 1 to 2 ratio. Can you see that? So there's 1 carbon and there's 2 oxygen. And it will always have the proportions. And it's regardless of whether regardless of how that carbon dioxide is formed, whether it's a sherbet in your mouth or from a car or from a volcano or whatever it is, the proportions for carbon dioxide, 1 carbon, 2 oxygen, will always be the same. And that's the law of constant proportions. So there's 2 things, I just want to remind you what they were. First was law of conservation of mass. That's that you don't have mass created or destroyed. And the second one was the law of constant proportions. And that's that the elements or the atoms within a molecule will stay as constant proportions. Makes sense. Good. Let's move on. The last thing I want to talk about is that sometimes the amount of energy that is required to start a reaction is more than you find just by shoving the 2 chemicals together. For example, the example I gave earlier in the video was hydrogen gas plus oxygen making water. Do you remember that? We were talking about that just 2 minutes ago or whatever it was. Okay, so of course we often have hydrogen gas being exposed into oxygen to the air, right? But we don't get large explosions and water falling out of the sky. That's not how rain occurs. I just want to occur, that's not how rain occurs. In order for that to happen, what we need is this heat factor. If we get hydrogen gas in the presence of oxygen, and then we blow it up, we'll find that water condenses on the side of beaker or whatever it is we set alight, okay? So sometimes we need this start ignition in order to force a reaction to come along, okay? Yeah, and that's basically what we've been talking about. I think that's all we need to discuss in this video. So just to go through it again, okay? There are such a things as reactants at the beginning of a reaction. These are called the products. This equation satisfies the law of conservation of mass. The amount of hydrogen is equal to the amount of hydrogen in the reactants is equal to the amount of hydrogen in the products, and the amount of oxygen is equal to the amount of oxygen in the products. And it also complies with the law of constant proportions. The water that we have here, H2O, is the same water that we would get anywhere else in the world. It's always H2O. Okay? So, go to chapter 7.1. Look up the blue words and put them into Quizlet. I'll see you in class. Bye.